So let's talk about writing or overwriting. Okay, we've got a linked list and we want to replace something. Well, we got two different options, right? We can either go to the node and overwrite the element. Our element is set up in a way that we can't do that, but that doesn't mean that you couldn't do it generally. Or we can just replace the node. Take the node with the element that we don't want out and put a new node in there. So overwriting is easy, okay? Get to the desired node and then call set element. But let me ask you something. Is this part of the overwrite process? Put a different way. Let's suppose I said, hey, I've already got a pointer to that node. We're already set, right? Well, no, this is access, right? This step is access. So when we analyze overwrite, we're going to ignore getting to the desired node. Yes, you have to do that, but that behavior can be abstracted into the access aspect. And so if you do this right, you might not need to get to the desired node. So really, we're just going to analyze this step when we get to our analysis part. Okay, so that's overwrite. We can also replace. And replacing is a little trickier, but it's really not that bad, right? So once we have the node before the node that we want to replace, let's think about this, right? What do we have to do? Well, we want that node to go away, but we want all other nodes after it to be the same. So we can create a new node that points to the node after the node that we want to replace, and then point the node that we're currently at to our new node. So if we have this list and we want to replace this guy, we can just do this. So quick question. That's pointer 1. That's pointer 2. Which one do we do first? Well, let's imagine. Let's imagine that we have, let me grab my highlighter and let's make it black, okay? Let's say that we don't do this, okay? There's no pointer here right now. And this is the state of our linked list. Well, now the question becomes, how do we get this, right? By separating this link, by axing this link here, we've lost the back half of our linked list. Now we can't get to that data. Conversely, let's axe this one. Let's say we don't change this yet. And we'll go and we'll leave this pointer here. Well, now look at this. We still have access to our entire list. We can get to this node if we need to, but we probably have a pointer to this thing, a variable called like new node or something. And that lives out here somewhere. And so we have access to this too. So we have access to all of our data. So the rule of thumb is you do the second pointer first, and then you take care of the first pointer, okay? And by doing this, we're not going to lose any of our data. But now that nothing's referring to this node, what's going to happen? Well, hopefully garbage collection will come. Hopefully garbage collection will come and take care of this for us. If you really want to be anal, and we'll talk about this some when we get to delete. If you want to be anal, you can, of course, nuke this reference. And if you really want to be anal, you can nuke this reference too, just to help point out to garbage collection that that thing is donezo. But really, garbage collection should realize it's donezo on its own and just get rid of it. So what's our runtime for either of these? Remember, we're ignoring getting to the node. We're ignoring getting to this node here in this case. So if we just have a pointer to if we wanted to replace this and we had a pointer to it, well, we're just overwriting a variable. That's big O of 1. This process we're creating a node, we're establishing a variable, we're establishing a pointer, and we're redirecting a pointer. Well, those are all constant time processes too. None of those depend on the size of our data. So big O of 1 plus big O of 1 plus big O of 1 plus big O of 1 is big O of 1, right? They're all constants. So overwrite is big O of 1 for linked lists. And it is also for arrays. Oh, so this is a push. This is a win for arrays. Things are not exactly looking good for linked lists right now. Okay, well, let's get to some other activities.